Hello and welcome back to AP Environmental Science. Today we're going to talk about conventional energy sources, and we're also going to review some of the energy concepts that we've discussed earlier in the course, and then we're going to add a little bit to it, some of the things that pertain specifically to generating electricity or producing energy for transportation, things like that. Okay, so first of all, let's review the laws of thermodynamics. The first law is, of course, the law of conservation of matter, and that's going to be really important because when you're generating energy, right, for all of these things that we do, whether it's turning on lights or driving our car, you start out with one source and then it becomes some other product through this conversion, and that's what we're going to talk about. And then the second law is that you always move towards an increasing state of entropy, which means lower states of energy, and ultimately that means that you're losing energy in the conversions. And when we're talking about energy in this sense, we're losing it to generally heat, okay? And in order to maintain the quality and the amount of energy we have, we'd have to put in more energy. And so what we need to do is find sources that have a high energy content, right? And that way when we lose some, as you know, is going to happen, we don't lose a lot, right? Now, the other thing too is don't forget that all movement, no matter what it is from high to low. Hot to cold, high voltage to low voltage, high pressure, low pressure, whatever. Okay, so let's talk about two new things, efficiency and quality. And these both go to the two laws of thermodynamics. And efficiency is how well you can convert the type of energy in your source into whatever your product is. And here are some of the things that you might see in your day-to-day life, with the exception of a wood stove. Of course, I imagine most of you don't cook on a wood stove. But your furnace is probably a gas furnace. The great thing is this is natural gas. We'll talk about that later on. Great conversions here, right? So you burn the natural gas, you get most of the energy that's released from that. Incandescent bulbs, on the other hand, these are the regular old light bulbs with the filament in them that glows. Horrible, huge energy losses. And when you talk about fluorescent light bulbs, whether they're fluorescents in buildings or they're compact fluorescents, there's still a lot of energy loss, but it's a lot better than the incandescent light bulbs, which is why people recommend compact fluorescents. And then candles, really, really bad quality there. And you can see that when you're burning wood or any type of, in this case the candle may be a petroleum-based wax, could be beeswax, whatever, not good conversions there, so low efficiency. Now quality is the other thing that you want to talk about, and quality is about the amount of energy stored in whatever the source is. You can, by burning coal, oil, or natural gas, get lots and lots of energy out of that. Nuclear power has even more, much higher concentration, is much higher quality fuel. Wood and the other biomasses, that's really low, and you can see that the combination of having a low quality energy plus a low efficiency does not make for a very good fuel source. So wood, peat, dung, things like that, they're not good options, although they're used all over the developing world. Okay, so when we talk about the comparison of the fuel content, right, and this goes to the quality, you can look, hydrogen is actually the highest quality, and we're going to talk a little bit more about hydrogen later on. It's not one of the conventional fuels. The rest of these here, these three, natural gas, petroleum, and coal, these are the fossil fuels, really good. Very high source of energy here, especially natural gas. Yeah, coal's the least out of them, and 38% is really, really good. But anyway, so, and then ethanol is one of your biofuels. We're going to talk about that when we talk about hydrogen, because it's one of your alternate energy sources. And then biomass is also a conventional energy source, but in the developed world, we don't really use it anymore. It's typically in the developing world. Okay, so conventional energy, this is what we do now. And we are really going to focus in this case on the developed nations, because it's the developed nations that are using lots of energy, okay? And developing nations really don't, actually, for the most part, except in large cities, stuff like that. So we're focusing on the developed world in this particular unit for the most part. So what do we do now? Hydroelectric, right? We generate electricity with that. Coal, we generate electricity with that. Oil, right, is used for transportation and lots of other things. It actually makes lots of products like plastics, but that's not part of energy production, so that's not something we're going to talk about right now. But anyway, so oil, transportation, natural gas is for heating and cooking, and nuclear is for electricity. So we actually have 3 ways that we generate electricity, all of which we're going to talk about, and they all have pros and cons. Okay. So, well, and actually we've already talked about hydroelectric and we've talked about nuclear, and so, you know, we're really moving on to the fossil fuels today. But anyway, so nuclear, we get about 20% of our electricity from nuclear. We get less than 10% from dams. This is the hydroelectric is through the dams. Coal is our number 1 source. That's 50%. Natural gas makes a great addition. So these are going to be the smaller plants. These are going to be your peak plants, for instance, stuff like that. And then oil is used in some cases, but it's really, really rare. Oil's main function is about transportation. There is fuel oil, which is used for heating in the north and the northeast. But really, when we talk about oil, we're talking about transportation. Okay, so which of the following is not an accurate description of electrical power in the U.S. at the present? Electrical power is a secondary energy source. Electrical power production consumes about 1/3 of fossil fuel production. Electrical demand has risen since the 1950s, but will likely decrease in the future. Electrical demand fluctuates with industrial use plus residential heating and cooling. Electrical power tends to separate points of consumption from problems associated with the point of production. Okay, so only one of these is not true, and that would be number 3, right? Electrical demand is going to go up for 2 reasons. Rising affluence, more electricity. Higher population, more electricity. So there's no decrease in the future, in the foreseeable future at least. So electrical power is a secondary energy source. It is a huge part of, well, 1/3 of the part of fossil fuel, right, consumption. And then it does fluctuate, right? At peak times, you're going to be using more electricity. When you're talking about summer, you're going to be using more electricity. Winter, you're probably going to be using less because a lot of heating is going to be done through natural gas, right? And so there's this nice fluctuation, and so it really depends on when you're talking about. And then electrical power tends to separate points of consumption with points of production. You have your house where you are getting electricity and you're using it, but that you don't live next door to the power plant, right? And so if you live next door to a coal-fired power plant, for instance, you would see that there's all kinds of pollution that is still released, even though they do a good job of containing some of that. It's still dirty. If you live near the mines, right, you're going to have all of this pollution, and we'll talk about mines later on. But you don't get to see that mostly, and so you have this separation. Ooh, radioactive waste, right? You don't have that in your backyard, so there's a little bit of separation there. Okay, so let's talk specifically about the fossil fuels. Fossil fuels used to be living stuff, mostly plants. I know that you'll hear a lot that when you're driving, you're burning up dinosaurs, but dinosaurs actually are really too young for the most part, to be fossil fuels. We're looking at stuff that is anywhere from, 70, 100 million years to 300 million years. Now, obviously, there are dinosaurs in that, but dinosaurs were a small percentage of the actual biomass. The majority of the biomass, so there are some dinosaurs in it, but the majority of the biomass was going to be plants. And so what happens is plants die. They accumulate at the bottom of bodies of water, and that gets incorporated in the sediment, and then over time, right, millions and millions of years, you have the formation of these deposits of coal, natural gas, and oil. It depends on heat, pressure, time, geologic structure as to what you get, okay, whether it's coal, natural gas, or oil. But it all started out as biomass, right, that ended up being incorporated into rock layers. And then later on, we pull it out and we use it, right, for all kinds of things. The big deal about this is that when you look at natural cycles, plants will take up CO2, right? And so as long as you're growing plants, you're constantly absorbing CO2. But natural gas, oil, and coal are plants from millions of years ago, and so there's not a natural balance for this. So what we do is we pull out this organic matter and then burn it, which just adds CO2, and there's no living equivalent. So we just dump more and more from these areas that were locked up before. And that's the big deal about the CO2 coming in. I mean, global climate change actually would be the big deal, but that's why you get so much more. Okay, so when we talk about natural resources, there's all kinds of categories. You've got discovered resources and undiscovered resources. That's probably pretty obvious. The discovered ones are ones that we know. The undiscovered ones are the ones that we are thinking are there or might not even know about, okay? And so proven reserves are things that we know are there and we can get to, okay? And so when you look over here at your degree of economic feasibility, this is how much money you're going to make. Degree of geologic assurance is how sure you are that they're there, okay? Known resources, you know it's there, but you don't really know how much. In the case of the proven reserves, you do know how much. Your recoverable resources, those are things that you can get to, but they're not economically beneficial, okay? And so the idea is that you would put more money into it than you would make, and that's not something that people are going to want to deal with. And so when you look at this, the recoverable resources, this is the economic threshold, okay? And so anything below this you're not going to want to get. Anything above this, perhaps. And then the undiscovered, that's its own little category. And then down here are the non-recoverable resources. These are things that are there, but we can't get to them, right? We don't have the technology to do it. Okay, so we are really, really, really dependent on fossil fuels. And so it is very difficult to think about how to replace these in a way that would be reasonable and provide all of the things that we need. Because if you look at this, this is a huge, huge amount of fossil fuels that we're using. I mean, nuclear is not very much. Hydroelectric's not very much compared to the rest of them. And so this is a difficult thing. How do you wean us off of this addiction that we have to fossil fuels? So we have to do it though, because when you start looking at the emission levels, first of all, nuclear is great because it has zero emissions, right? We already talked about that. But when you look at natural gas, out of the three fossil fuels, natural gas is really the cleanest. It releases the least amount of carbon dioxide. It has a little bit more carbon monoxide than oil, but way less than coal. The NOxes, the nitrogen oxides, not very much. Very little sulfur. Not a whole lot of particulate either because it starts out as a gas, and then there's zero mercury in it. Oil, a little bit better until you hit sulfur, right? That's not very good. So right here, when you get the NOxes and the sulfur dioxide and the sulfur oxides, that's not great. Mercury, not really great, but a lot less than coal. And coal turns out to be pretty nasty when you start running down all of the emissions from this. And we'll talk specifically about coal later on because some of these things you can do something about and some of them you can't. So, or at least at this time, you can at this time. But we'll talk about that later. Okay, today I want to talk specifically about natural gas. This is the only time we're going to talk about what natural gas is and what it's used for. Oil and coal we will actually focus on separately, and we'll go into a little bit more detail. But natural gas is fairly simple. The majority of it is methane, some of it is propane. Okay, it's got some trace other gases in it. It's a distillate of petroleum, so natural gas and oil hang out together and they're called petroleum, and this is the lightest. And so once you start actually distilling the crude oil, which we're going to talk about in just a second, the first thing that will come off of that is going to be this methane, this natural gas. And in some cases you can have a whole natural gas deposit, but you can also get it out of oil deposits too. Okay, so what do you do with it? Heat and cook. Right? Heating and cooking typically is what you do. Gas stoves, gas furnaces, there you go. Okay, so natural gas deposits occur in the greatest amount above reservoirs of crude oil, in methane hydrate crystals found in the Arctic, in the atmosphere, or stored in permafrost. Well, if you said with oil, you would be absolutely correct. Remember, those hang out together. When you're talking about permafrost, right? Permafrost does have methane, okay, and there is methane in the atmosphere. Cows produce methane, all that good stuff. But when you're talking about a deposit, that is going to be where you're drilling for it. It's going to be a large amount, and it's going to hang out with oil. Okay, so natural gas is the world's third largest commercial fuel. It is almost 25% of global energy consumption. And the great thing, though, is it produces, like I said, half as much CO2 as coal. And because it is more available. Natural gas used to be something that people didn't really pay very much attention to. And as a matter of fact, when you go to an oil refinery, a lot of times they were burning off the natural gas. And so you'd see these flame stacks at oil refineries. And that flame was actually powered by natural gas because they weren't collecting it. But now that we've figured out ways, really efficient ways to generate electricity, sometimes it can be used as fuel for cars, then it's becoming much more appealing. And so there's a lot more drilling for natural gas, and we're doing a lot of that in Texas. Some of you may actually live near natural gas wells. Okay, one of the disadvantages of natural gas, though, is it has a relatively low net energy yield. It's difficult to transport from one country to another. It produces more air pollution, or supplies are very low. Well, we already know it's got the highest quality. We know that it produces less air pollution, and we know that there's actually a lot of it, which is why we're trying to exploit it more. And by a lot, that's relative. But anyway, it's really difficult to transport, though, because it is gas, right? You can transport oil through a pipeline because it's a fluid. You can push it down the pipeline. A gas will simply compress. You can't do that. Coal, you can truck. You can put it on ships, right? But again, with the gas, that's a difficult thing. So it kind of has a limited range. All right, so let's talk a little bit about oil. Here you see this nice 1800s oil area with all these little wells on it, little boomtown action going on. It is the primary source of energy for transportation. It makes diesel, aviation fuel, gasoline, all of those things. Unfortunately, the history of oil has not been very clean. It has typically supported what we call a drill, spill, and kill legacy, which means that you go in, you drill for the oil, you're not particularly careful about what happens with it, and that causes groundwater contamination, it causes soil contamination, and that leads to the death of plants and animals and microbes in ecosystems. That is getting a lot better now as people are becoming more conscientious and oil companies are becoming more conscientious about cleaning up and things like that. So this is better now, but historically it has not been good. All right, now the other thing about oil is that you can't just pull it out of the ground and use it. You can do that with natural gas, but for oil, you have to refine it, and that means to separate the products. And when you do through distillation, and when you do that, you use energy and you release all kinds of pollutants, NOxes, SOxes, all kinds of those things, and carbon dioxide. Okay. And there are more sustainable alternatives available if we just kind of focus on those. And it's probable that it'll take a long time to stop using oil entirely, and in some cases we won't stop using it. But the goal would be to use less and for transportation, and that's the point. Okay, more later on this. But really quickly, I do want to look at the distillation process. Here you've got your gases. This is going to be natural gas. So what you do is you burn it, and you see what evaporates off. And you will actually be doing distillation later on in the course when we start making ethanol from corn grain. But here are some of the things that you get. Fuel oil, you can burn this for heating, like I said, in the northeast. Lubricants like Vaseline, waxes, like you see in candles. Diesel oil is exactly that, it's diesel fuel. Kerosene is lamp oil. Gasoline, obviously you're familiar with that. And what you're seeing is these things get lighter, so they are smaller carbon chains as you go up, right? Methane is 1 carbon, propane is 3 carbons, for instance, so you go from there. Okay, coal, a little bit about coal. It is the primary source for generating electricity. It is the dirtiest, we saw that. It's really cheap, actually, but it has to be mined, and so that has all of its own problems. We'll talk about that later, too. Different types of coal. There is lignite coal, bituminous coal, and anthracite. Lignite is a soft, lower quality coal. It's great for electricity. Anthracite is the hardest and the oldest. It's also the rarest, but it has the highest energy content. And when you're talking about making steel, coal is really important in making steel, and you need that anthracite, or you need very high quality bituminous. That's a lot harder to find. As a matter of fact, in the United States, you're really looking at Pennsylvania is where you find the biggest anthracite deposit, which is why you had a lot of steel manufacture in Pennsylvania. Okay, but again, there are more sustainable alternatives that we're going to talk about. So given the amount of pollutants and the carbon dioxide, we need to start downshifting on the use of coal and start mixing in much more sustainable alternatives. Okay, more later on that too. All right, so let's match the dominant fuel with its secondary energy source. So the primary energy source is going to be what you're converting from. The secondary energy source is what you're converting to, right? So oil-based fuels, what are those? That's right, transportation. Natural gas, what is that? That's right, heating and cooling. Coal, what is that? Industrial processes and electricity, right? So industrial processes and electricity. And then nuclear power, that is electricity, yeah? And the reason we put coal in industrial processes is because, remember, it is the thing that makes steel, right? So it has this as a secondary source. I'm not saying that coal is used predominantly, like the majority of coal is used for industrial processes. No, the majority of coal is used for electricity. Okay, so what about us, the U.S. and energy? We use lots of energy, but this, when we look at the global energy supply, this is what we have. We have a lot of oil, but we use a lot of oil. We have a lot of coal, we use a lot of coal. We have a lot of natural gas, we use a lot of natural gas. And then, so here are the things that we're going to talk about later on, right? The combustible, renewables, and waste, and like I said, we'll get to those later. We've already talked about nuclear and hydroelectric. Okay. So when we start talking about energy consumption, you can see that typically energy consumption goes up with affluence. Not always, right? But it's a pretty typical increase, right? They're directly proportional for the most part. Oh, and why does the UAE use so much oil? Or energy, sorry. Because they have lots of oil and they can. Okay, so energy consumption in the United States, we use a lot, right? Most of it's oil. Then you're going to see natural gas. Then you're going to see coal, because we have transportation stuff. Then nuclear, sometimes wood and renewables, not really so much, and then water. Okay, so who actually consumes the most oil? Well, we do. Back to this graph, we do. So we use about a quarter, and then the next biggest country usage is Japan, and then you start moving down from there. But one of the things that a lot of these countries have in common is that they are small, which means that they are places you can walk or ride bikes, or they're not developed, in which case you have people who don't have cars and might have some sort of draft animal, something like this. But in this case, we're talking about fewer cars, right? And although China is going to start increasing because they are getting lots more cars. Okay, so where do we get our oil? This is a really good question, and it comes up a lot. The majority of our oil actually comes from us. The next largest supplier is Canada, right? And then you start moving into the OPEC countries, Saudi Arabia, Venezuela, Iraq, Nigeria, all of those guys. And yeah, and so we get a lot of it there. The problem is that the oil coming from Venezuela, the oil coming from Nigeria, the oil coming from the Middle East, has some ties to it that can sometimes threaten either the economic benefit to us or the political situation. Nigeria has a fairly unstable government, and so oil prices fluctuate as Nigeria fluctuates. Venezuela and the Middle East have a more politically unstable relationship with us. Okay, so in 1973, the OPEC countries that were the Middle Eastern countries initiated an oil embargo, and so we were not able to import oil. So which of the following would be a response to a decline in the amount of oil, a decrease in the amount of oil? All of these are the responses except legal speed limits were reduced, legislation was passed to improve fleet fuel efficiency, domestic exploration for oil was increased, alternative energy sources were investigated, or an efficient nationwide public transit system was established. Actually, the first four all are true. right? The last one was public transit. We didn't really start looking at mass transit at all. And so speed limits, the faster you drive, the more gas you use. Higher fuel efficiency means less gas. Being less dependent on foreign oil, right? That would be domestic oil. That would be better. And then there was not a lot done here with the alternate energy sources, but it was investigated. It just wasn't followed through on. But no national public transit. No push for that. Okay, so how do we use energy? Industry consumes a lot, right? But it turns out that unlike water, residential and commercial buildings, so office buildings, homes, stuff like that, actually use more energy than any other sector, whereas with water, it was agriculture, industry, then residential, commercial. In this case, it's residential, commercial, then industry, and then transportation, right, is the next one. So that's the big pull there. Okay, so about half of all the energy in the primary fuels is lost when you are converting it to the useful forms while you're shipping it and while you're using it, and that goes to efficiency, okay? And so what that means is that about 2/3 of the energy that's stored in coal is lost when you're generating electricity. And actually it's a little bit less than 2/3. They're running at about 38% efficiency, but that means that you're losing 62%. So, and then once you generate the electricity, you lose energy going down the transmission lines and going through transformers from the plant to people's houses. Okay, so when we look at the flow, this is just a big overview of what you start out with and what you end up getting, right? And so useful energy from about all of these, about 37%, right? And then the lost energy is going to be the rest of that. Okay, so emission levels, once again, right, when we start looking at CO2, okay, because before we were looking at pollutants, but CO2, hydrogen, 0, because there's no C in there, and this should be a subscript, sorry about that. Natural gas, that's the least, right, then petroleum, then coal. Ethanol and liquid petroleum, like gas, are actually about the same, and so there's no benefit CO2-wise, except that ethanol comes from plants that are growing now, and we'll come back to that later on. And then biomass, wood, stuff like that, that's going to release the most. Okay, now there's something that you can do. There's lots of things that you can do to save energy, but one of the big things that buildings are starting doing and houses are starting to do is to do what's called cogeneration. And typically companies, right, buildings, big buildings, apartment buildings, all of these would use the power lines, right, for electricity. So there's a central power station that's generating electricity. And then they would use another fossil fuel for heating and hot water. And so you would have these two separate sources. But a lot of places are starting to look at something called cogeneration. And so what you do is you generate electricity on site, right, through a variety of means, and then you use the heat that comes off of that electricity generation to heat the building, right? And so you end up using the same fuel for both of these functions, and this waste heat is actually from the electricity, which is lost. So it's this waste heat right here is captured to heat the building. It's very, very smart. Okay, now the other thing that we have to consider, so we can use less energy by just being smarter, by capitalizing on what's lost and using that. But the other thing is carbon sequestration. We have the CO2 problem, okay? And so there are 4 big things that are done with it. It can be stored in plants. So the more trees that you plant, the more CO2 gets locked up in them. And that's true for agriculture. I mean, crops will also take in CO2. So more agriculture means more CO2, all of those things. But green stuff, right? You can also inject it into aging oil fields. And you can use it, and we'll talk about this later on, to actually help get oil out of oil fields. And then saline aquifers, when you have saltwater intrusion in an aquifer, it's no longer useful for drinking water. So you could actually inject CO2, excess CO2, into it. You can lock it up in minerals, right? So things like carbonate salts, like magnesium carbonate, stuff like that. And we'll come back to that later on. And then ocean storage is the other, that you just inject it into the ocean, you bubble it in the ocean. This is the worst possible choice because, referring back to our global climate change discussion, that makes the ocean more acidic and that starts threatening marine ecosystems. So that's not a good choice, but these are some of the options, and we'll talk about them more as we go through the course. All right, if you have any questions, please let me know next time, and I will see you later.